Hello, everybody. Today I'm going to be doing the problem solving from chapter 1. We will be going through all of the example problems in chapter 1. I find them to be a very good representation of the knowledge that you are supposed to know. So watch these videos, go along with the problem, solve them until you understand them completely. Solve them 1 time, 2 times, 3 times, whatever it takes, until you are every time you solve them, you will get more insight into the subtleties of physics. All right, so example 1. Says the world land speed record of 763 miles an hour, miles per hour, was set on October 15th, 1997 by Andy Green in the jet engine car Thrust SSC. Express this speed in meters per second. Okay, so we will do this. In order to express this in meters per second, I have to convert the miles to meters and I have to convert the hours to seconds. Now I know that 1609 meters equals 1 mile. And I know that 3,600 seconds equals 1 hour. So what I would like to do is get meters in the numerator and get miles out of there. So I'm going to multiply this by 1609 meters over 1 mile. I can do this because this expression right here is equal to 1. We call this unity. So if I multiply any value by 1, I don't change the value of my expression. Similarly, I want to get rid of my hours here and get seconds there. So I will do this: 1 hour, 3,600 seconds. And my answer will be, let's see, 341 meters per second. Example 1-2, converting volume units. One of the world's largest cut diamonds is the first star of Africa, mounted in the Royal British scepter and kept in the Tower of London. Its volume is 1.84 cubic inches. What is its volume in cubic centimeters and cubic meters? This is a great example because this allows you to convert a dimension that is raised to a power to a different dimension that's raised to a power. So we know that its volume is 1.84 inches cubed. And I need to convert that into centimeters. Now I happen to know that 2.54 centimeters equals 1 inch. But this is a cubic dimension, remember? So what I have to do is I have to do 2.54 centimeters over 1 inch, quantity cubed. I have to cube everything in that parentheses. So let's see. I'm going to go with their example. I haven't, oh, here's my calculator. Let me just do that. I'll go ahead and do it thoroughly. 1.84 inches cubed times, here, 2.54 raised to the power of 3. That will give me a 16.38 inches cubed. And then, of course, 1 cubed is just 1 inch, and that's cubed as well. Remember, if I have to do a quantity cubed, that means everything inside the parentheses is cubed, including the units. And I will get 30.2 centimeters cubed. Okay, now I have to convert it to meters, correct? All right. So I'm going to go ahead and use that 30.2 centimeters cubed, and I'm going to convert to meters. Now I know that 100 centimeters equals 1 meter. So let me go ahead and write my expression for unity, 1 meter over 100 centimeters. And this is going to be, remember, we're dealing with cubic units. So once again, this is going to be quantity cubed. So I'm going to get 30.2 centimeters times 1 meter cubed over 100 centimeters cubed. And that's going to be what, 10 to the negative 6? That's going to give me 30.2 times 10 to the negative 6 meters cubed. Example 1.3, significant figures in multiplication. The rest energy E of an object with rest mass m is given by Albert Einstein's famous equation E equals mc squared, where c is the speed of light in a vacuum. Find E for an electron for which, to 3 significant figures, the mass equals 9.11 times 10 to the negative 31 kilograms. The SI units for E is the joule. Recall that when performing multiplication, your product can have no more significant figures than the amount of significant figures in the value with the fewest significant figures. We have been asked to solve for E from the equation E equals mc squared. So solving for E, we have E equals, we are given the mass, 9.11 times 10 to the negative 31st kilograms. And C is the speed of light, which you can look up and find to be 2.99792458. Times 10 to the 8th meters per second. And this quantity is squared. Performing that operation gives us 8.18765 9678 times 10 to the negative 14th kilograms meters squared over seconds squared. And recall that the value with the fewest amount of significant figures is this guy. It has 3 significant figures. So I need to round, and if I'm going to round, that will be 8.1, and this is going to be 9 because this value 7 is larger than 5. So my final answer is going to be 8.19 times 10 to the negative 14th kilograms meters squared divided by seconds squared. Example 1.4 is an order of magnitude estimate. The problem says you are writing an adventure novel in which the hero escaped with $1 billion worth of gold in a suitcase. Could anyone carry that much gold? Would it fit in a suitcase? All right, gold, you have to look up several quantities for this. Gold is worth $1,400 an ounce. $100, which makes $100 worth of gold equal to 1/14 of an ounce. 1 ounce is 30 grams. So $100 of gold is just about 2 grams. He's got $1 billion worth of gold, which is 10 to the 9th. And that equals 2 times 10 to the 7th, since 2 grams is 10 to the 2nd worth of gold. 10 to the 2nd dollars worth of gold, excuse me. So 10 to the 9th worth of grams, 10 to the 9th dollars worth of gold, my bad, is about 2 times 10 to the 4th kilograms. This is a very, very heavy amount of gold, which no human being can carry. So no one could carry this amount of gold, and your novel needs a bit of reworking. Example 1.5 is adding two vectors at right angles. Example 1.5 reads, a cross-country skier skis 1 kilometer north and then 2 kilometers east. On a horizontal snowfield. How far and in what direction is she from the starting point? First, I will add these two quantities graphically. I'm going to use 5 kilometers to indicate, 5 centimeters to indicate 1 kilometer. So my first 1 kilometer north will look like that, and then 2 kilometers east. Let's see. Going to be 10 centimeters here. Oops, right there. All right. Taking this from tip to tail here. Let's see. Here. Oh, let's do this. Right there. Very hard to do this on the whiteboard here. Ugh. Wow. Let's see. Sorry about this. All right. Let's see. Measuring this vector from, why is it doing that now? Here to here, we will get, let's see. All right. All right, if I measure this distance to here, I will get 2.24 kilometers, or 2.24 kilometers times 5 is going to be what? 11.2 centimeters. And my angle will be 63.4 degrees. Another way to do this is with the Pythagorean theorem. So r is going to equal the square root of x squared plus y squared. We have a 90-degree angle, so we can do this. So r is going to be equal to the square root of 1 kilometer quantity squared plus 2 kilometers quantity squared, and that's going to be equal to 2.24 kilometers. To find the angle, I will use the fact that tangent theta equals y over x, so tangent inverse of y divided by x is going to give me my angle. So let's go up here, tangent inverse of 2 kilometers divided by 1 kilometer is going to give me an angle of 63.4 0.4 degrees. And when you do this, a little word to the wise, make sure your calculators are going to be in degree mode. Degree mode. Example 1.6 asks us to find the components of vector D. Vector D has a magnitude of 3.0 meters and an angle, theta, equals 45 degrees. So d sub x and d sub y. D sub x is going to equal 3.0 meters times cos 45. And d sub y is going to equal 3.0 meters times sine of 45. And we're going to get, for this one, is going to be a plus 21 meters. Let's see, a vector. Let me stop right here. Okay, resuming, I see from the example that vector D is in the fourth quadrant. So it's going to have a x component is going to be positive, and x, and the y component is going to be negative. So cosine and sine have the same value. Therefore, the y component is going to be a negative 2.1 meter. The x component is going to be a positive 2.1 meter. Part B asks us to find the components of this vector, vector E, which has a magnitude of 4.5 meters and is measured, beta is an angle from the positive y-axis at 37 degrees. That makes the angle from the positive x-axis 53, because that would be 90 minus 37 is going to equal 53. All right, to calculate this, we get E sub x is going to be equal to 4.5 cos 53. And E sub y is going to be equal, it's meters right here, 4.5 meters sine 53. Respectively, this is going to be 2.7, positive 2.71 meters. And this guy's going to be equal to positive 3.59 meters. Example 1.7, using components to add vectors. Okay, 3 players on a reality TV show are brought to the center of a large flat field. Each is given a meter stick, a compass, a calculator, a shovel, and in a different order for each contestant, the following 3 displacements. The 3 displacements, A is 72 meters at 32 degrees east of north. B is 57.3 meters, 36 degrees south of west, and C is 17.8 meters due south. The 3 displacements lead to a point in the field where the keys to a new Porsche are buried. 2 players start measuring immediately, but the winner first calculates where to go. Where does she calculate? All right, let's determine. Okay, for the components of A, this is A right here. It is 32 degrees east of north. This is north. This is 32 degrees east. I'm going to use this value, the 58 degrees north of east. So I will be A sub x equals 72.4 meters times cos 58. I know this is going to be a positive value that lies in the first quadrant. And A sub y equals 72.4 meters times sine of 58. Let's see what our values are here on clear. 72.4 times cos 58 equals, this is going to be equal to 39.95. And clear, 72.4 times sine of 58 is going to equal to 61.39. Okay, just to clarify, I made a little mistake with the calculator, and this is not 39.9. This is actually 38.3. So the components of the first vector, the x component is 38.3 meters. And let me put meters there. And the component, the y component of the first vector is 61.39 meters. Doing the same process with vector b sub x and b sub y. And this is vector b right here. And I see it's going to lie in the third quadrant. Therefore, both my x and y components are going to be negative. So it has a magnitude of 57.3. So b sub x and b sub y. It's going to be equal to the magnitude, 57.3 meters. 57.3 meters. And this is the angle with respect to the x-axis is 36. So this is going to be cos 36. Remember, it's going to have a negative value. And once again, this is going to be sine 36. It's going to have a negative value. Let's figure out what those are. Clear 57.3 cos 36. That's going to be equal to a negative 46.36. That's my x component. I'll put it here. And my y component is going to be 57.3 times sine of 36. That's going to be a negative 33.68. All right. Finally, for my c component, this is my, 1 minute. My c component is here. I see that it only has a y component. It has no x component. So its y component, x component is going to be 0. It is due south. Its y component is going to be a negative 17.8 meters. Now, to find my resultant vector, r, I'm going to get my x and y, my Cartesian coordinates of x and y by adding them up. My r in the x is going to be, I add these three up. This guy is supposed to be negative as well. Is going to be a negative 7.99. My y component is going to be a 9.92. We would like to convert from Cartesian to polar. So to get my vector is going to be my r. This is r sub x and r sub y. My r total is going to be the square root of the sum of the squares. So these are in meters once again. So r is going to be negative 7.99 meters quantity squared plus 9.92 meters quantity squared. And it's going to be 12.7 meters. To find the angle, I will take the tangent inverse of y over x. So that's going to be tan inverse of negative 7.99 meters divided by 9.92 meters. And this is going to give me an angle of negative 51 degrees. So my polar coordinates are 12.7 meters at a negative 51 degrees. Example 1.8, I am given two vectors, two three-dimensional vectors, and I am asked to find the magnitude of 2d, vector d, 2 times vector d, minus e. We will call the new vector f, and it is the result of these two operations. So I will add each component by component. So F is going to equal 12I minus 4I plus 6.00J plus 5J, 0.00J, plus a negative 2.00K minus 8K. And these are all in meters. The units are meters. So let's go ahead and do that. And my answer is going to be 8.00I plus 11.00J minus 10.00K. Once again, my units are meters. These are my Cartesian coordinates. If I want to find my polar coordinates, I will do F equals the square root of the sum of the squares. So if I want to find my distance or my magnitude, it's going to be 8.00 meters, quantity squared, plus 11.00 meters, quantity squared, plus a negative 10.00 meters, quantity squared. And my magnitude is going to be equal to 16.9 meters. In example 1.9, we are calculating a scalar product. So we are asked to find the scalar product of A dot B given these two vectors. This is A right here. It's got a magnitude of 4 and an angle of 53 degrees with respect to the x-axis. And Y has a magnitude of 5 and an angle of 130 degrees with respect to the x-axis. To find the scalar product of A dot B, we take the magnitudes of A times B times the cosine of the angle between them. So in this case, we have 4 times 5 times the cosine of 130 minus 53 gives us 4 times 5 times cosine 77, or 4.5. To verify, we could also use this same A dot B and multiply each of the components. A sub x times B sub x plus A sub y times B sub y plus A sub z times B sub z, and we will get the same answer, 4.5, or the magnitude of A dot B. Example 1.10 asks us to find an angle with the scalar product. So it's asking us to find the angle between these two vectors. And to do so, we're going to use this relationship. We know that A dot B equals AB cos theta. So cos theta has got to be A dot B over the magnitudes of A and B. So recall from the last example that A dot B is also going to equal to the sum of the products of each of the components. So if I have the sum of the products of each of the components divided by the magnitudes, I can solve for the angle. To solve, I'll find the magnitude of the vector A. I will take all the components and take the square root of the sum of the squares to get the square root of 14. Similarly, I will do the same process with vector B. I will take the square root of the sum of the squares of all its components, and I get the square root of 21. Now to solve for A dot B by components, I will take the sum of the product of each of the two vectors, x, y, and z components, and I get a -3. So recall that the cosine of theta is going to equal to A dot B, vector A dot B, over their magnitudes. And that would be -3 over square root of 14 times square root of 21. That's cos theta is going to be equal to -1.175. So cos inverse of -1.175 is going to equal theta, and theta will equal 100 degrees. Example 111 asks us to calculate a vector product. We are given vector A has magnitude of 6 units and is in the direction of the x-axis. Vector B has magnitudes of 4 units and lies in the xy plane, making an angle of 30 degrees with a positive x-axis. Find the vector product of C equals A cross B. A, once again, is magnitude 6. My angle theta is 0. B is magnitude 4. My angle, I'll call it phi, is 30. So C will be A cross B, which is AB sine beta. Well, I'll call the angle between them beta, which is 6 times 4 times sine of 30. I get the magnitude to be 12. To find the direction, I will use the screw rule. I'm taking A cross B, and I will find that is into the page.